Hey everyone, welcome back to our channel. Today we will dive deep into the linear regression, understanding its theory, applications, and even a practical use case. Let's begin. Linear regression is a powerful tool, especially in scenarios like profit estimation for companies. Imagine you are an investor and you want to know the profit potential for a company. We will take a simple example of predicting profit based on research and development expenditure. By analyzing how much a company invests in R&D and its resulting profit, we can make informed investment decisions. To understand the linear regression better, let's start with the basics of the machine learning. In machine learning, we deal with various algorithms categorized into supervised, unsupervised, and reinforcement learning. Today, we are focusing on supervised learning, especially regression. Let's see how linear regression fits in. Linear regression is a technique used to predict the relationship between independent and dependent variables. An independent variable denotes as x doesn't change due to other variables, effects like rainfall. In contrast, a dependent variable denotes as y changes based on the independent variable like crop yield. Before we deliver deep, let's distinguish between numerical and categorical data. Numerical data involves numbers like age or salary, while categorical data involves descriptions like color or gender. In supervised learning, we already have labeled data and we use it to train our models. Regression, a subset of supervised learning, aims to predict continuous values within regression together a different type like simpler linear, multiple linear, and polynomial linear regression. Simple linear regression. It involves drawing a straight line through data points to predict the relationship between the variables. Let's take our rainfall and crop yield example again. We plot the data and draw a linear line that through it. This linear helps predict crop yield based on real rainfall. Now let's look at applications of linear regressions. It's used in various fields like economics, predicting product prices, housing sales, and even sports score predictions. For instance, it can help estimate a country's economic growth or forecast the price of a product. Now let's understand the theory behind linear regression. It's all about finding the most accurate line that predicts the relationship between variables. We use basic formula y is equal to mx plus c, where y is the dependent variable, x is the independent variable, m is the slope, and c is the intercept. To calculate the regression line, we use equation geometry, finding the slope and intercept. The slope indicates how much the dependent variable changes for a unit change in the independent variable. The intercept represents where the line crosses the y-axis. To make things clearer, let's consider a simple data set. We take 5 data points and plot them. Then we calculate the means of x and y, which represents the average values. Plotting these means help us drawing line through the data, giving us a good estimate. Thanks for watching the video.